Assalamu alaikum wa rahmatullahi wa barakatuhu. So children, we have completed two chapters in mathematics, right? Triangles and circles. Now on from these two chapters, I'm going to give you a small test, okay? So I'll be sending you the test quiz on somewhere in the middle of this week, maybe Wednesday, okay? So before that, we'll just go over whatever we have learned, okay? It's just a revision. So let's start with the triangles chapter. Okay, so here see, your test is going to be multiple choice questions. Okay, so I'm not going to ask you to solve any problems and show it to me on the board, or I mean like how we do it in the normal test, no, like that you don't have to solve anything and show it to me, but I'll be asking you questions where calculation may be needed. So you'll have to do the calculation somewhere in a rough note or something, and you should choose the answer. Okay, I'll be giving you 4 options, only one will be the right answer, so you'll have to choose only one correct answer. If you choose 2 of the answers, even if one of them is right, you won't be getting the score. Okay, and also the theorems and all, okay, the proving, the statement, all those things, though I had asked you to learn and memorize those, but in the test which I'm going to give you, it's a quiz, so it's just a MCQ. I won't be asking you all that. Okay, you just have to learn that and understand it. Based on those theorems, you will be getting numerical problems only. Okay, but in board exam you'll be asked to solve, prove the theorem. Okay, statement and proving both will be asked. Okay, so you'll have to remember that. Now here you just have to understand it and learn to solve problems based on the theorems. Okay, now let's come to the chapter. So see here, similar figures. When I say that two figures are similar, like what do I mean? They look alike, right? They are not equal, they look alike. Okay, they are not equal in the sense the shape and size are not same. Only the look wise, the shape is same, not the size. Okay, so that's what is called as similar figures. Now when two triangles are similar, so when will you say that two triangles are similar? Okay, so here, if say the statement says two triangles are said to be similar if their corresponding angles are equal and the corresponding sides are proportional. Only 2 rules. Okay, the angle should be equal and the corresponding sides are proportional. I have taught you all this. This is just a revision. Okay, now if you have have 2 triangles like ABC and PQR, now look at this. Now if I say that these 2 triangles are similar, that means that angle A is equals to angle B. See, I have written both A and P in the same ink, right? See, same gray pen. And angle B and angle Q are equal to each other. This and this are equal. And angle C and angle R are equal to each other. Okay. So now if that is the case, then the corresponding angles are equal. Then I will be writing triangle ABC. Since I wrote A first, A is equals to P, I will be writing P first here. And B is written second, so I'll write Q second. And C is written third, so I'll write R third. Okay, so ABC is similar to triangle PQR. This particular symbol over here, it says it is similarity symbol. Okay, all right. Now come down to your next thing. See here, I have written that A is equals to P, B is equals to Q, and C is equals to R. Now this is what your first statement says, that the corresponding angles are equal. Now what do you mean by corresponding sides are proportional? That is AB, see, AB over PQ. So I write the first 2 alphabets over the first 2 alphabets of the other triangle should be equals to BC over QR, and that then should be equals to AC and PR. Okay, so this is what you mean by corresponding sides are proportional. Now let's just review the exercise 2.1. So you people would have solved it already, written it on the board book, but still we'll do it. Okay, fill in the blanks using correct word given in the bracket. All circles are congruent or similar. Now what do you mean by congruent? Congruent means equal. Okay, especially in figures we don't use the word equal. Like if I say you and your friend had equal number of chocolates, that is the number of chocolates I'm talking about, so I can say that it's equal. Okay, but when I talk about a figure, I will not say that it's equal, I will say that it's congruent. Okay, so here the circles, all the circles in the world, are they congruent? No, they are definitely not congruent, but they are similar. See, I can have one small circle, one large circle, right? They are not equal, they are not congruent, but they look alike. They are circles, all the circles look alike, so they are similar, okay? And all squares are similar again. Okay, you can have a smaller square and a larger square, so they look similar, but they are not congruent. And all triangles are similar. What kind of triangles are similar? Isosceles or equilateral? See, if I say isosceles, I can have a isosceles triangle like this, where this and this are equal. Isosceles means two sides are equal. I can have an isosceles triangle like this, right, where this and this are equal. Now these two are not looking alike, right? They are not similar. But equilateral triangle means all the three sides are equal. So I can have a smaller equilateral triangle, a larger equilateral triangle. All of them are going to look alike. So equilateral triangles are the ones which are similar, okay? Now, so two polygons, let it be not only the triangles, let it be anything of the same number of sides, are similar if their corresponding angles are equals. Angles should be equal, okay? It is not said as proportional. Angles are equal. The number is supposed to be the same and their corresponding sides are proportional. The same thing for the triangle, whatever I had written, it's applicable to for any kind of a polygon, okay? I mean any kind of a figure. Okay, now state whether the following quadrilateral are similar or not. So we have to show say if these two figures are similar or not. Now if you look at this has got 1.5, this has got 3. So that means what is it? See, if I multiply 1.5 into 2, it's double of 1.5, right? So this is double of 1.5. So if I multiply by 2, I get it. This is double of 1.5. See, everything, all the sides are 1.5, 1.5, 1.5, and here all the sides are 3, 3, 3. So all the sides are proportional, right? The corresponding sides are proportional, because when you multiply 2 with each side, you get the other bigger figure, right? So it's like, similar, I mean, it's proportional, but the angles are not equal. See, look at this angle. This is 90 degree, it's given to you. When they draw a square box, it's 90 degree, but this is definitely not 90 degree. So the angles are not equal. So because of that, it's not similar, okay? If it is similar, it should satisfy both the cases. Now come to basic proportionality theorem. So we know that if in a triangle ABC, if DE and BC are parallel, see, if it is parallel, I'll be marking it like this, okay? This arrow means that they are parallel. Then AD over DB, see, this over this will be equals to this over this, okay? That is what it says. Alright, now based on this, you'll be asked certain problems. So, if you have ABC and this is given as 5, this is 4, and this is 8, this is not given to you, okay? They are asking you what's AC. So first we'll find out this, okay? So let me take this as, let's first write it by BPT. You get AD over DB equals AE over EC. So AD is 5 over 4 equals AE, we don't know, so we keep AE as it is, okay? AE over EC. Now we can cross multiply, or you just have to find the AE. So you have a 8 at the bottom, move this 8 to the other side. So if you move it this side, it gets multiplied, right? Here it was at the bottom, now it will go and multiply on top. So you get AE is equals to, see, 4 ones are 4 twos are, so you get AE is equals to 2 into 5, which is 10. That's your AE, okay? This is 10, but they are asking you to find AC. So AC is total AE plus EC, right? So AC is equals to AE plus EC, 10 plus 8, which is 18, okay? Now converse of BPT. Converse of BPT is, the reverse thing. Like, if you have a triangle where AD over BC, I mean AD over DC, if this over AD over DB, sorry, this over this is equals to AE over EC, then these two lines are parallel, okay? So here this is the condition given to you, and if these two are equal, then the sides, the DE is parallel to BC, okay? Now the next thing is, now if you have a triangle like this, okay, ABC and CDE are similar to each other. So A is 30, so obviously C will be 30, right? Here C is equals to 30, okay? Now they are asking you what's D. So D will be equals to the B, but we don't know what is B. B is not given. So first we'll look at the figure. See, this is 100, and this whole thing over here is actually 180, isn't it? This whole thing, it's a straight line. So this whole thing is 180. So if I want to find this little angle over here, how will I find? I will use 180 minus 100, which is equals to 80, right? So this I found it as 80. So this is my C. So if this is 80 and this is 30, see, in a triangle you should have all the three angles equals to 180, right? Correct? So angle A plus angle B plus angle C should be equals to 180. So here what do you have? Angle A is 30, angle B we don't know, angle C is 80. This should be equals to 180. So 30 plus 80 is how much? 110 plus angle B is equals to 180. So angle B is equals to 180 minus 110, which is equals to 70. So if angle B is 70, angle D will also be, because both are in the middle thing, right? So angle B is 70, so angle D will also be 70. So that's what they're asking you to find. So this will be 70 and this will be 30 and this will be 80. Okay. So now this was, the first page of your triangles revision. You have one more page, so let's just continue with that. Okay, so look at this. Okay, so now this is, in this page we are going to learn about the theorems. Okay, there are different types of theorems to prove that the true triangles are proportional. We are of course not going to look at the statement and the what is it called, the proving and all, but we need to know how it works. Okay, see, there is a theorem called AAA criterion. Okay, here it says that if there are two triangles, see, you can read the statement and see later on. Now you see here A, B, C and P, Q, R, if these two triangles are they are having the angles, all the three angles are equal to each other, like A is equals to P, see, I have marked it red and red, B is equals to Q and C is equals to R, then by AA criterion the two triangles are similar. Understood? If the three angles are equal, then the two triangles are similar. Okay, now here, okay, now if you have, if in two triangles, see the second one. Okay, so so also in the first first theorem, not only the three angles, even if two angles are equal to each other, I mean two corresponding angles are equal, then the third angle automatically turns out to be equal. So you can also have a AA criterion. Okay, triple A or just double A, both will work out. Okay. Right, now come to this. Okay, if in two triangles sides of one triangle are proportional to the sides of the other triangle, then their corresponding angles are equal and hence the two triangles are similar. So now similarly, this is the SSS. Okay, when these two triangles are having the corresponding sides are equal, like AB and AB by PQC, the brown and the brown, and then AC by PR, that is the orange and the orange line I have drawn, and BC by QR. If they are all proportional, then the triangles are said to be equal. Okay, now come to the next one, theorem 2.5. This is SAS. Okay, so here obviously, as I say, SAS, S goes for side, A goes for angle, and another S goes for side. But the side angle side means the sides, two sides angle should be sandwiched in between, like this. Okay, two sides, if I'm talking about AB and AC, then I should have angle A only. I can't have angle B or C. Okay, angle A should be equals to angle P. Okay, now if I'm talking about AB and AC, now if AB is AB by PQ is equals to AC by PR and A is equals to P, then the two triangles are said to be similar. Okay, now here you come to this. So this is again, it's just for for the sake of your to answer few numerical problems, we are learning this theorem. Actually the proving is not there for this. Okay, I mean this year it's been excluded for you guys. Okay, so now the ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. So you know that if two triangles are similar, so now if I'm saying that these two triangles are similar, I will actually write AB by PQ is equals to AC by PR is equals to BC by QR, isn't it? But now if I'm talking about the area, this is actually is equals to perimeter. You know perimeter, right? P goes for perimeter. Let's say triangle ABC divided by perimeter of triangle PQR. Okay, but when it comes to the area, it all will be squared. All of it will be squared like this. See, AB by PQ the whole square, AC by PR the whole square, everything will be squared. Okay, sides are all equal to each other, even the perimeter is equal, but when it comes to area, it is squared. Okay, now come to Pythagorean theorem. So we all know a Pythagorean theorem. It is like involved with the right triangle only, right? See, when I say right triangle, you know that the Pythagorean theorem goes as both the sides squared and added will be equals to hypotenuse square. Now here the main thing is you should know which is your hypotenuse. Okay, the angle is 90 degree over here, so the side opposite this 90 degree will be your hypotenuse. This will be your hypotenuse. Okay, the other two are sides. This is a side, this is again a side. Okay, or we can just call it as arms of a triangle or a legs of triangle. Okay, now here in this case this is 90, so this will be your hypotenuse. Okay, here this is 90, so this will be your hypotenuse. Okay, so now in the first case what will I write? AB square plus BC square, because sides should be squared, should be equals to AC square, because hypotenuse should be the longest side is the hypotenuse is always the longest side, and that should be written after the is equals to sign like this. Okay, the other two sides added together, squared and added together, will give you the hypotenuse squared. Okay, here what will I write? PQ and QR are the sides, so PQ square plus QR square is equals to PR square. And in the third case, what do you have? XY square plus XZ square is equals to YZ square. Okay, now see here you have something called as Pythagorean triplets. This is just for you to save time. See, if I say that, if you can remember this, it will be well and good. If you have a 3 4 5, see, this is one thing you can remember. It's like, if you have a right triangle, always the longest side is the hypotenuse. Okay, now if you have 3 and 4 as are the two sides, then the hypotenuse is 5. So you can remember like this: 3 4 5. This 3 and 4 could be here also, but hypotenuse will be always over here. Okay, that always 5. So 3 4 5 is one triplet. Okay, now based on this, and then again you have 6 8 10. 6 8 10 is actually from this 3 4 5 only. How did I get it? I have just multiplied all the three things with the 2. So 3 2s are 6, 4 2s are 8, 5 2s are 10. Okay, so and it goes on, 3 3s are 9. I can multiply with any factors. Okay, so this, if you can remember, it's good. Okay, 3 4 5, and then you have another one as 5 12 13. Then you can remember this 7 24 25 and so on. Okay, if possible you just remember a few, the simple ones. Okay, all right, now come here, look at this. In triangle ABC, if AB square and plus BC square is equals to AC square, so see here they are telling you the two of the sides is equals to the third side, then definitely the side opposite AC is going to be 90 degree. Now how will you know what is opposite AC? So you know that ABC is there, right? Let us say I'm just randomly drawing. Okay, ABC. Now let me just draw a normal triangle. Okay, I don't know now if it is 90 degree or not. Okay, I'm just drawing ABC. Okay, now they are saying that AC square, this is your AC. Okay, AC square is equals to AB square plus BC square. So definitely this is going to be your hypotenuse. So the side opposite this hypotenuse, that is B, is going to be your 90 degree. Understood? So you can remodify your triangle and you can draw it like this: B as 90 degree, A and C over here, or A and C the other way around also, not that doesn't matter, but B is 90 degree is what is important. Okay, because how do you figure that out? You say that what is AC? AC is what is your hypotenuse, so the angle opposite the hypotenuse will be your 90 degree. Okay, now come to this point. In triangle ABC, if AB and BC are equal, then it is called as an isosceles triangle, right? You know that if two sides are equal, it's an isosceles triangle. Then if these two sides are equal, then the opposite angles will be equal. That is, angle opposite this side is this, and angle opposite this side is this. These two angles will be equal. Okay, now if you have a triangle like this and you have this and this equal, then this angles will be equal. Okay, if I have a triangle like this and I say that this and this are equal, then this will be equals to this. Understood? So it's all about the base angles are equal. All right, now coming to this next point. In triangle ABC, if AB is equals to BC, okay, so that is an isosceles triangle, and one of the angle is 90 degree, B is equals to 90 degree, then the triangle is called isosceles, right? isosceles right triangle, because it's also isosceles, it's also right triangle. So in that case, what will happen? You will have, see, ABC, this and this are equal, they have told. So this is 90 degree, it's given. So if these two are equal, then these two angles will be equal. Let me keep it as x. Okay, I'm trying to find out what x is. So if I add all the three angles A, B, C, it should give you 180. A is x, C is also x, B is 90. So I have solved this. So x plus x, 2x plus 90 equals 180, or 2x equals 180 minus 90, which gives you 2x equals to 90, or x could be written as 90 by 2, or x is equals to 45 degree. So each angle is 45 degree. One angle is 90, the other two are 45. In case of, so this is a case of isosceles right triangle. Understood? Okay, so now that's all about your triangles chapter. Now based on this, you may get numerical problems, word problems also, based on the Pythagorean theorem. So it's very simple. Okay, just go through it, solve problems, just revise it well. Okay, now we'll just look at circles also. Okay, because you'll be getting, we have completed both the chapters, so we'll be revising both these two chapters. You'll be getting a test on both these chapters together. Okay, so yeah, so prepare well. So now circles is a very small chapter, right? So now here, let's just quickly review this. See, the tangent at any point of a circle is perpendicular to the radius through the point of contact. So see, if you draw a tangent to a circle, see, let's say I draw a circle. Okay, I'm just drawing a circle, and I'm drawing a tangent anywhere. Let's say I'm drawing a tangent over here. This is the center, right? If I draw a radius joining this particular center and the point of contact, see, this is the point of contact, this will always be 90 degree. Now if I have a tangent like this, then if I join the radius to this, this will be 90 degree. If I have a tangent like this, if I join this will be 90 degree. Understood? So radius always meets the point of contact of the tangent perpendicularly. Understood? So this theorem proving and all is not required for this test. Okay, I'm not going to ask you the proving and all. But you need to know the know how to solve problems based on that. Okay, the basic statement you should understand. Okay, now let's revise exercise 4.1 quickly. How many tangents can a circle have? So you can have many tangents, right? So you have a circle, you can keep on drawing so many tangents, right? So you can't even count how many tangents you can draw. So you have infinitely many. All right, now come to the next one, fill in the blanks. A tangent to a circle intersects it in one point. If there is one tangent, and that particular tangent can intersect the circle at only one point, it can't intersect at more than one point, right? If there is another tangent, then you will say this particular tangent will meet at one point. So one particular tangent meets the circle at one particular point only. Okay, a line intersecting a circle in 2 points is called a secant. Now it just says line. Okay, line means what? It can go both the directions like this, right? That's what is your line. Now if it intersects the circle in 2 points, then it is called as a secant. Okay, you can't call it as a chord, because chord actually ends, right? It's not a line, it's a line segment actually. See, it just stops here to here. This is a line, it's just going. So this is a secant. Okay, all right, now come to the next one. A circle can have infinitely many parallel tangents at the most. That is, see, you have a circle. Okay, you have parallel tangents. See, there will be two parallel, one pair of parallel tangents. See, this is one set, there could be another one, right? Now I can draw many like that, correct? I can draw many parallel tangents. See, this is one set. Now let me draw another set. Let's say I have another set like this one and this one, right? And so I can draw so many. So there are infinitely many. So the common point of a tangent to a circle and the circle is called point of contact. So as I said, if you have a circle and a tangent, the point where the circle and the tangent meet is called a point of contact. Okay, point of contact. All right, that's what they have asked. All right, now come to the next question. A tangent PQ at a point P of a circle of radius 5 centimeter. See, so I'm drawing a circle, okay, of radius 5 centimeter. So now first thing is, in these kind of questions you should know how to draw the circle. So see, I have already drawn the circle, but now I'll show you how to draw it step by step. So it says that a tangent PQ, so there is a tangent PQ at a point P of a circle radius 5 centimeter. So there is a circle, okay, of radius how much? 5 centimeter. Let me draw a radius 5 centimeter circle. Okay. Now they are saying there is a tangent PQ at point P of a circle. So at point P, let's say I have a point P over here. I have to draw a tangent which is, which is at point P like this. Okay. This is the tangent, okay, at point P. Okay. Now a tangent PO, sorry, is it PO or PQ? One minute. Yeah, it's PQ. So a tangent PQ at a point P of a circle. So a P is on the circle and Q is somewhere over here. Let's say I draw a Q somewhere over here. Okay. Okay. Meets a line through the center. So the center is O. Okay. At a point Q. Okay. So this particular point Q. So that OQ is 12 centimeters. So this is 12. Find the length of PQ. Understood? So you need to draw it carefully. So that's what I have drawn over here. A circle is there. It's the center is O. From Q, its OQ is 12 and PO is 5. Radius is 5. And we know that, from the first point that it will always be 90 degree, right? So now we need to find out what is QP. So now if this is 90 degree, the side opposite this is going to be your hypotenuse. So OQ is your hypotenuse. Okay, so the other two sides OP square plus QP square should be equals to OQ square. So OP square is 5 square plus QP we don't know. QP square is equals to 12 square. So 25 plus QP square is equals to 144, or QP square is equals to 144 minus 25. So QP square is equals to 119, or QP is equals to square root of 119. So option D is the right answer. Okay, now come down to this question 4.2. The lengths of tangents drawn from an external point to a circle are equal. That is, see, if there is a point P and I am drawing tangents PQ and PR, then PQ and PR are always equal. Okay, so they are tangents, and this is always obviously equal because these two are radius, right? So they are equal. Okay. Now let's say that you have a circle and you have a point P, and you're drawing a tangent like this. Then this and this are 90 degree, we know that, right? Because it's radius and tangent, they are perpendicular to each other. So in a quadrilateral, so this is actually a quadrilateral, no, a four-sided figure. So in a four-sided figure, sum of angles of a quadrilateral is always equals to 360 degree. You should remember this. So we have got 90 plus 90 already 180. So these two should add and give you 180. Okay, these two added together should give you 180. Got it? If I add this and this, it should give you 180. So now so that's what I have told. See, I have just solved how I got that. Okay, so because these two are adding up to 180, so the remaining two should add up to 180 only, then it will add up to 360. Okay, so now here sum of opposite angles is 180 degrees. Alright, now here I see based on this you may get a problem. So if I give you a circle like this and they have given you POQ as 110, what is PTQ they are asking you? This is what they are asking you. So what will you do? You will have to, that these two are 90 and 90, so this is not required at all. These two should add up to 180. This plus this should give you 180, right? So 110 plus PTQ should add up to 180. So PTQ is equals to 180 minus 110, which is 70. So this is 70 degrees. Okay. Sometimes they may ask you what is this angle. They may just slit it like this and they may ask you what is this angle. So you will have to divide 110. Or sometimes they may ask you what is this half angle. So the 70 should be divided into two parts, so 35 degree. Okay, so anyways they can ask the question. So the basic thing you should know is the opposite angles add up to 180. Okay, so now that's it. I have revised whatever is possible. Now you just go over the notes which we have covered so far, and also try to solve problems and get ready for the test. Okay, in middle of this week I'll be giving you a test. Okay, all the best, prepare well. Allah Hafiz.